This is a recording for pre-calculus for Thursday, 2/28, and there will be two recordings today. The first one will be the end of 6.1, and then the next one will be the beginning of 6.2. And so we were working on a problem, but because we have people testing today, I should have given you two handouts. Here's one of the handouts. You should have completed those, and now you should be checking your work just to see how you did. And I'm going to tell you that before you check your work, maybe you want to look at or revisit that second problem. And just a reminder that the angle here is 22 degrees 50 minutes, and so you might have hopefully you've converted that by saying that's 22 plus 50 over 60 to get your decimal degrees. If you didn't, you might want to pause this before you check your work. So now you're just going to check your work on these two worksheets. This is the first one, and so here should be the answers to that. And if you need to look at it longer, you can pause that. If you have any questions, you can ask me tomorrow in class, or if you're working on this right now in class, you can ask me right away. Here's the second handout, and so hopefully you've answered those as well, telling the number of triangles for each set of conditions. And so then to check that, here's my kind of scratchy work there. And again, if you have questions, you can either ask me now if you're doing this in class, or you can ask me tomorrow as well. And so there's the first four. And then I'll scroll that down, and here's number 5. So I wanted you to do those, and now we'll just finish this problem that we had been working on. And we had just gotten the length of C, which is 5.15 kilometers. And we have all of the angles. We have that ratio that we need. And so next I would find maybe the little side A as we look at that. And excuse my, I have a little catch in my throat. So for that, the sine of 88 degrees over 8, we can kind of use that same ratio, is equal to the sine of 52 degrees over little a. Cross multiplying, we get little a equals 8 sine 52 degrees over the sine of 88 degrees. When we put that in a calculator, we get that A is approximately 6.31 kilometers. And our question is to approximate the total distance for the course. And so I'll write total distance is equal to 8 plus 6.31 plus 5.15. So it is 19.46 kilometers. And so that is that problem as well. I do have another optional problem. I'll maybe just hand that out to everybody. If you have questions on it, you can ask me, and we can look at that maybe on Friday if there are any questions. And if you don't want to do it, that's your business as well. We'll just move on to the next lesson now. And so let me just kind of check real quick. And I think I am done with these. So then we're going to, maybe I will make this all one recording, we'll see. Then I didn't realize I didn't have that much to do in that one. So this is 6.2 law of cosines. Since you're recording this, you can, or excuse me, since I'm recording this, you can kind of look at things as you go and make a decision of if you need to pause it and everything. I'll just kind of move along as we go. So the law of cosines is something that we can use when we can't use the law of sines. Remember, for the law of sines, you have to be able to find an angle and an opposite side where you know both of those, or you can figure them out before you start the problems. So what kind of problems would lead you to not be able to use the law of sines? Kind of think about that a moment, and then we'll see. If we have a side case where we know the three sides, no angles, then we can't do that pair for law of sines. And when we know side, angle, side, so kind of think about my triangle, I maybe know this side and that angle. Well, if I know angle C, but I don't know little c, I can't make that ratio. And if I only have that one angle, I can't find a second angle to make that ratio either. And so then we'll use the law of cosines to model and solve real life problems. We'll use Heron's area formula to find the area of a triangle. That's a, little used, I would call it, area formula, but really the one that when people have asked us landscaping questions, that's often a way that we answer a landscaping problem for our, people who ask us questions about things like that. And so here's the introduction. These two cases for oblique triangles, when you're given three sides or two sides and the included angle, the ratios of the law of sines can't be used, so we use the law of cosines. And what I'd like to do really quick is, there we go, I'd like to use one form of the law of cosines to kind of derive the other. And so if you've done the law of cosines before, the version you would usually use is c squared equals a squared plus b squared minus 2ab cosine capital C. So this is the version you would use if you know, and I'll just kind of do this like here's A, or excuse me, there's A, B, and C, and little a, little c, and little b. So in this case, you would usually use this to find that little c when you know little a, little b, and big C. So you know this side, you know this side, and you know that angle. So, that kind of the two sides that make that angle and then that angle. If you know that, it's pretty straightforward. Maybe you can see the Pythagorean theorem in here. That's why I kind of use this version a lot. And if it's a right triangle, the cosine of 90 degrees is 0. And so then that all is just gone if it's a right angle. And so that's how we get the c squared equals a squared plus b squared. Kind of back to our old Pythagorean theorem that we're used to using. So that can also help you kind of know that formatting. And then the other thing is that, let me get rid of some of that. Then when we find c, we just take the square root. And of course, it's the positive square root because c is a length as we go through that. Now, let me get rid of some of those things that I've written on there because I want to take a minute or two and actually derive. So what if I know the three sides and I want to find the angle? And so, we're at a point in our math life that we should be able to know the relationship between two versions of a formula as we go. And so really we want to get this capital C alone and think about how we would do that mathematically. Well, I would get rid of things that are added and subtracted. And just notice that's all multiplied. So you're not going to get rid of that first. And I think we'll subtract a squared and subtract b squared at the same time. And when we do that, then we get c squared minus a squared minus b squared equals, these cancel, that cancels. Don't forget that negative 2 is there, a b cosine c. Then, since we want to get c or the cosine c alone, we're going to divide by the coefficient of cosine c, which is negative 2ab on both sides, negative 2ab. And then that's going to give us, just over here, c squared minus a squared minus b squared over negative 2ab equals cosine c. And then just to kind of think about, I often just use this version, but mathematically we don't like to have negative in the denominator as a factor. And so what we might do, that's one version. And you know, a corresponding version would be then that c is the inverse cosine of all that, c squared minus a squared minus b squared over negative 2ab. And but if I want to kind of clean that up, and that's what our book authors would do, then I'm going to take this one, and maybe I'll just clone it a second. And oops, just a second. There we go. And now I'm going to take that and say, you know what, it would just be prettier, I guess, if I multiply the top and the bottom by -1. And so on the bottom, I'll get that positive 2ab. Then up here, I'll get negative c squared plus a squared plus b squared over 2ab equals the cosine of c. And then, you know, I don't like it to start with a negative right here. And so I don't like to have my first term be a negative, and then I'll put them back in that order. And so let me get rid of that a sec. And then that would give me a squared plus b squared minus c squared all over 2ab is equal to the cosine, oh, I had forgotten the c there, is equal to the cosine c. And you'll see that that's the one that our book authors give here. So if we want the cosine of c, or we want to find angle c, it's a squared plus b squared minus c squared all over 2ab. And then c is the inverse cosine of a squared plus b squared minus c squared all over 2ab. I will say these versions, typing in is kind of the hardest, but this is a good version to use when you know all three little sides and you have to find the angles, because that's all that you need to know. And just make sure you know which angle it is you're finding, and it's the one opposite that c squared in that formula that you're using as you go. Then here's just, you know, a listing of these formulas. And so to me, if you can know one, you can know all of them, because they kind of use these patterns. And so just take a minute and write down whatever you want of that. Definitely you want to write down these two versions, and you want to know those two versions. So the one on the left here, I'll maybe erase the star for a minute. The one on the left with the star is the one you would use when you have two sides and the included angle. You know those, and then you're finding that other side. And then the one on the right, now that has a star, is the one you would use when you know all three sides and you're finding the included angle. So take a minute, write that, and then I will make this the end of the first recording, and then we'll do a problem or two after that and in the next recording.